we've got a cosine. Woo, that's nice and complicated. Okay, so we have cosine of
bracket cosine inverse open parentheses negative root 2 over 2 close parentheses minus pi over 2 close brackets.
This is about as complicated as they get. I suppose we could have made it slightly more complicated by making this sine or something, but
Couldn't we just make it tangent?
you want to make it tangent?
No.
Sure, we could put tangent right there. Why not? Okay, so same thing here. We're going to work from the inside out just a step at a time. It looks complicated, but if we do it a step at a time, it's not a problem. So we're not going to panic. Okay, we know what this value is. Hooray. Nice. This is the one that's a little bit quirky for us. So what is cosine inverse of negative root 2 over 2? Now before you answer, stop and think. Cosine inverse, what part of the circle is it defined on? And is it on this top part of the circle or is it on the side here? It's going to be on the top because cosine, stop and think this. On a unit circle, cosine are which values? My x and y values.
X.
They're my x values. Okay, now look at the unit circle. I need all the possible values, x values. I need all the possible positive values, and I need all the possible negative values. If I take this 1 and 4, what are my x values? They're all positive, so that can't be it. I have to have positive and negative x values, so it has to be quadrant 1 and 2. So this is where I get my values from. Okay, so then my second question. This is negative square root of 2 over 2. Is that going to be first quadrant or second quadrant? Because those are my only two choices. It's going to be second quadrant. So I know that my answer needs to be in quadrant 2. Good. So the question is, in quadrant 2, when does cosine equal the square root of 2 over 2 negative?
3 pi over 4.
It's at 3 pi over 4. It's the 45-degree angle going this way. So this is 135 degrees, but we need that in radians because our problem is in radians. So in radians, that's 3 pi over 4. So we're just going to replace this with 3 pi over 4. So now we have cosine of 3 pi over 4 minus pi over 2. Now I ask you, does this look that difficult? No, it's at that point it's simple arithmetic. This looks difficult. This looks difficult because this looks intimidating. It's not intimidating. So what is 3 pi over 4 minus pi over 2?
Pi over 4.
It's going to be pi over 4. If I common denominator this, that's 2 over 4. So I'm left with
2 over 2.
Cosine of pi over 4. What is cosine of pi over 4?
Root 2 over 2.
It's root 2 over 2 because this is my 45-degree angle. The trick with cosine inverses and sine inverse and tangent inverses is don't panic. The only thing that makes the inverses difficult, I think, first of all, they look weird. We're not used to looking at inverse notation, so just looking at it's a bit of a shock and intimidating. Don't let it intimidate you. The second thing that makes it difficult is you need to pay attention to your quadrants. But if you get used to doing exactly what I've showed you for each problem, the first thing I always say, I've been doing this for years, okay? I still ask myself the same question every time I start a cosine inverse, sine inverse problem. I say, what quadrants am I dealing with here? Because I know that sine has to be either quadrant 1, or sine inverse has to be quadrant 1 or quadrant 4. Tangent inverse has to be quadrant 1 or quadrant 4. Cosine inverse has to be 1 or 2. So I ask myself, what quadrant am I dealing with?
Pretty much guaranteed one of them's 1.
Yeah, 1 seems to come up a lot. That's right. You notice 3 never does.
Yeah.
And then, then the next thing is to look at my unit circle. Either to picture it in my head, which I can do. If you're still working on getting the unit circle pictured in your head, pull out your unit circle diagram and let it help you so you can find the angles. Does this make sense? Okay, great.